Hello, this is Mrs. Slater, and quote of the day: be not afraid of greatness. Some are born great, some achieve greatness, and some have greatness thrust upon them, by William Shakespeare. All right, today we have two goals. First goal, graph exponential functions. Second goal, we are going to graph logarithmic functions. All right, so let's begin. First of all, exponential functions are functions in a different notation that you are used to. We have f of x equals a to the x, where a is some positive real number, constant, different than 1. Okay, the notation you're going to start seeing on this is f of x again, because it definitely is a function, and then a to the x, or you may also see it as y equals a to the x. And in both situations, the variable will always be in the exponent. So that differentiates different graphs. Is when the variable's in the exponent, you know it's an exponential graph. The x and the y are going to be points on the graph, which we'll get to those in a second. Now, before we go on to the next one, logarithmic functions, those are also very special because they are the inverse of the exponential function. So everything you learned yesterday's lesson will apply with these two inverse functions. Okay, the notation you're going to see, now this is very new to you, f of x, and you have log a of x. Now, I'm going to say it the way you should say it in class. Log base a, because that will signify what is that little number, of x. Okay, so then you will also see y equals, same thing, log base a of x. And when you are writing it, the log, the y, the log, and the x are all the same font. And then the subscript is the base a. We're going to call that the base a. And once again, the x and the y will be points on the graph. Keep that in mind as well. Okay, so when we go to our first exponential graph, we're going to complete the table and plot the points to see what this graph actually looks like. Okay, here's our exponential function. Notice the variables in the exponent. We're going to plug in a 2 to get 4, and then plug in a 1 to get 2, and then you get 1, 1/2, 1/4. Let me move this down a little bit, 1/4, and then 1/8. Now notice it never quite is getting to 0, and that's going to be the case if we keep continuing putting in negative numbers. So let's plot those points at 0, 1, 1, 2, 2, 4, and then 1/2, 1/4, 1/8, 1/16, 1/32, and so on. It'll never quite get there, ever, ever, ever. But putting those arrows showing that it's going on forever. So there's our first exponential function ever graphed. All right, now the domain, notice it goes all the way to the left. So that's a negative infinity, and it goes all the way to the right. Got that arrow going, so that's going to be positive infinity. The range is going to be 0. Even though it never gets there, it's always heading toward that, so we're going to put a parenthesis noticing that, or just show that it's not included, but it's definitely going to that point. And then infinity, you can see that it goes up to infinity. The y-intercept is at 0, 1, right there, y-intercept. That's a good one to know because that's going to end up being one of the key points right here. 0, 1, 2, 4, and 1 and 2. Whoops, I meant to do that earlier. And 3, 8 if you wanted another one just to make your graph look better. Okay, so now let's go ahead and translate graphs. Okay, right here I have a red and a blue graph right on top of each other. This is what we just got done graphing. And I put this here just so you could see the translation. It says 3 units to the left. So you can take all those key points and move 3 units to the left. Let me start over here. So 3 units. Let me get it over here. And then 1, 2, 3. Let's see if I can get it there. Very good. So then you can see that this common point at 1, 0, 1 is now 3 units to the left. The key point at 1, 2 is now 3 units to the left. And same with 2, 4, it's 3 units to the left. So that is our new function, just translated 3 units to the left. And how would we write that? Okay, we know if it shifts left to right, it's going to affect the x value. So we have 2, and then, you guessed it, we have to do the opposite here. So it would be x plus 3. Okay, and then on the next one, if we're shifting it to the right, I'm going to go all the way to the right. 4 units, that would be our new point. And going back to our shifting, 0, 1, 1, 2, 3, 4. There's our new point. 1, key point 1, comma 2, shifts over, and there you go, and there you go. So how do we describe this? Is y equals 2, and then once again, you have to think opposite here. It'd be minus 4 because we are going to the right. So take a second, push pause, go ahead and make sure you have those drawings in there, especially the red one, not necessarily the blue one, but make sure you have the red one drawn in your notes. Okay, let's go on to reflecting. When we reflected before, it always had something to do with a negative. This one, if we're reflecting over the y-axis, our key points, again, are at 0, 1, and 1, comma 2, and 2, comma 4, and then it gets closer and closer to 0. So if I just leave those there in black, and then I reflect over the y-axis, it's going to reflect. The 0, 1 doesn't reflect at all. 1, comma 2 would now be negative 1, comma 2. See, that's just symmetrical over the y-axis. This one, same thing, mirror image over the top. The blue one, I'm going to go ahead and put that there, and then it would go half, a fourth, an eighth, a 16th, and so on. So I'm going to connect all of those and not going underneath the x-axis because it never quite gets to the x-axis. It's always, yeah. So then the equation for this, if it's reflecting, again, it's affecting the x-axis, or the x's, so it would be y equals 2 to the negative x. But you're not always going to see it like that. Sometimes they'll put it in, we know that negatives can flip the base number, which is 2 to 1/2, and now we can say it's 1/2 to the positive x. So look for either one of them and in your homework or your classwork. All right, so let's go ahead and look at logarithmic functions. Okay, so as you already know, it should be the inverse. So do not write this. So if this one goes like this, then the exponential should look something like this because it is that mirror image over that, right? So just keep that in mind. This one right here would be the log. Whoops, I picked up the eraser too soon. But just to prove it, I do like to go through some steps on what we have here. So log y equals log base 2 of 2. Log base 2 of x. And if this is the inverse of the exponential, here's the exponential. And again, we talked about yesterday, inverse, we're going to switch the x and y's around. So x would equal 2 to the y. So this notation means the exact same thing as x equals 2 to the y, but it's just in fancy notation, okay? So just keep that in mind. So it makes more sense to plug in values for y, and that's why I want to look at that. So x equals 2 squared. That's 4. X equals 2 to the first power. That's 2. And so on. That's 1. And then we have negative 1. I'm sorry, 1/2. When you plug in negative 1, you get 1/2, 1/4, and then 1/8. Okay, so look at all of those points, and if you compare them with the exponential, they are all flipped as you did in the previous section. All right, so let's plot some points. 4, 2, 2, 1, 1, 0, 1/2, negative 1, and we all of a sudden have getting closer to the y-axis without ever getting there. So if you connect all those dots, it's going to look something like that. And there is another point here that I missed. that I'd like to include just to make my graph look a little better. All right, so there's your logarithmic functions. All right, domain. We've got a negative infinity. No, we don't, because we have it gets closer and closer to 0 without crossing over it. So from 0 to infinity, it goes on forever. And then range is going all the way down, so that's negative infinity, and it goes all the way up, so that's going to be positive infinity. And what's going to be important on this one is the x-intercept this time. So at 1, 0, very important to know. And some key points that you notice when you're graphing were 0, 1, 0, 2, 1, 4, 2, and 8, 3 if you want to use that one for a better graph. Okay, let's go on to the next one. Now we're translating. How do you move 1 unit to the right? So let's look at this purple one. And if I move 1 unit to the right, it's going to stop right there. So some of those key points have just shifted over 1 unit, 1 unit. And where's the other one? 1 unit right here. Okay, and then the equation, we're affecting the x values. So you may have already written this down, but you have log. We're in base 2 because of this. We're just shifting base 2. And in parentheses, we're going to make it x minus 1. Because we're going to the right, we got to think opposite with what's inside the parentheses there. Okay, and then this one, we're going to go 3 units to the right. So I'm going to take this, 1, 2, 3, and go ahead and let's write down the equation, which would be y equals log base 2, and if we're shifting to the left, x plus 3. So take a second, push pause, make sure you have the purple ones drawn accurately on in your notes. Okay, so we'll end with a few examples. And here's the first one. Changing the base a little bit, it's no longer a 2. So what's going to happen is we are going to have plug a couple numbers in. So we have just 1. If we plug in 0, we get 1. And then plug in 1, we get 5. So there is the essential thing about exponential, if you get those two. And then it's just going to go closer and closer and closer to the x-axis. And it's going to be a little steeper than y equals 2 to the x. Domain, negative infinity to infinity. The range is going to be from 0 to infinity. Very good. Okay, and then this one is going to be a reflection. Remember how we talked about a reflection? This would just be a 5 to the negative x. Okay, and then if we reflect the first one, this one will not change. And then the 1, 5 would now be negative 1, 5, and then it will get closer and closer to the x-axis again. Giving you a graph that looks something like this. Okay, always push pause if you need some extra time to write those things down. Domain is from negative infinity to infinity, so that's not going to change. And then it is closer and closer to 0, so that's going to be a parenthesis on that one. Okay, so let's go on to the next one. Here we have x plus 2, so that means that we're going to shift to the right. And if we shift that to the right, think of what the key points were at 0, 1. So 2 units to the right is going to be here. And at 1, 5, and that's going to shift it here. And then it's just going to get closer and closer to the x-axis. So we've got the shift done. Negative infinity to infinity. It's not going to change with the shifting left to the right. And it still can't get to 0. So it's going to be 0, infinity. All right, and I think the next one here, I have the base back again at 2. So keep that in mind when you're shifting, because this is going to be a shift to the right 1 unit. So at 0, 1, shift it 1 unit to the right. And then at 1, 2, think of our key points. 0, 1, 1, 2, 2, 4. And that's what I'm going to shift. And then a 1, 2 shifts to the right. 2, 4 shifts to the right. And then these just keep going down by halves. And then you have a graph that looks something like that. All right, so it looks like we have negative infinity to infinity and 0 to infinity for that. And it looks like the last ones I want you to go ahead and practice. And this will be the first thing that we will talk about in class the next day. So go ahead and go on to the next ones, do the next 4, and see if you can get those shifts done correctly. And then we'll talk about them tomorrow. Have a good day.